Alrighty, so to continue on from concepts we saw in the previous two questions, and moreover, what the result of this shows you is going to be used in a few questions. So let's dive into how to think about things in equivalent forms. So here we want to show that the second equation in Maxwell's equations can be expressed in terms of the field tensor F mu nu as follows, where we have the partial of the field tensor with respect to lambda, mu, and nu, but every time we do that, we shift the field tensor indices. So if we have a lambda here, it's mu nu. If we have mu here, we have nu lambda, and we have nu here, so we have lambda mu. And of course, we're saying that's all equal to 0. So consider this something like a vector identity, except now we have a tensor identity, and this is going to be used somewhere else. But let's recall that the Maxwell's equations are written in the tensor form as such. Now, again, be careful of the notation that we saw with how to write things in the shorthand partial notation, because it'll be used, of course. So let's dive in. All right, so the solution is that the second equation is partial g of mu nu with respect to x nu is equal to 0. So if we write that in a shorthand, that gives us partial nu g mu nu equals 0, which based on the form is equivalent to the two homogeneous Maxwell's equations, namely the divergence of b equals 0 and the curl of E is equal to negative B, the negative partial of T of B. All that we have to show then is that when we put in the shorthand, partial lambda F mu nu plus partial mu F nu lambda and all that equals 0 is equivalent to them. Now this equation stands for 64 separate equations, i.e. because we know that mu goes for 0 to 3 indices, nu does, so we have 8 times 8 times 8, so, or excuse me, yeah, no, 16, 16, 16, so yeah, we have a lot of stuff to deal with. So 4 cubed is equal to 64. And so we see, but many of them are redundant or trivial. So let's actually look at the case by case for things of when the indices are, say, mu equal nu. That's the case with F mu mu, which of course would go to 0 because we saw the main diagonal is equal to 0. So that being said, we're left with one of these situations. And of course, since it's anti-symmetric, we could switch the order at the cost of a minus sign. And if that's the case, then we see that the derivatives forms cancel to 0, plus on this side, minus on this side. So this reduces to 0 equals 0, which is trivial. So to get anything significant, mu, nu, and lambda must all be different. Okay, and here's where the grunt work starts. So they could all be spatial, i.e. mu, nu, lambda equal 1, 2, 3 equals x, y, z, or some permutation thereof. So or one temporal and two spatial, which we can see permutations of, but we can examine two cases separately and then try to conclude from that. What we say is that if it's all spatial and they all have to be different, u equal 1, nu equal 2, lambda equal 3, put it in there and let's see what's going on. So if this is the case, the partial of 3 gives us z of dz, of bz, excuse me. And then partial of x with respect to bx, partial y with respect to by. Well, that all has to equal 0. And we see how that transforms into divergence of b equals 0. So pretty cool. Again, just be very, very careful with this because all we're trying to do is verify that this holds, and the left-hand side does indeed hold to the right-hand side. Now let's see what happens when we have one temporal, i.e. we have to go back and see what's up with the curl equation now. So here then, if that's the case, let the parameters be these. and plug in the field and derivatives respectively. Again, be very careful of the signs on the temporal side. That being said, let it cook through and you'll see what you get. The negative sign has to come over here because you have b on one side and e on the other. Why? Because then this shows that this is actually the z component of the curl of e, and you see that we have the negative bz there. So it kind of writes itself out and we can verify. So what we can conclude is that this does equal 0 is equivalent to the homogeneous side, which is delta b, or delta, which is the divergence of b, or nobula dot b, and then the curl of e is equal to negative b, or excuse me, the negative time derivative of b, and hence we could show that the derivative of the dual tensor leads to 0 too. Again, this is only there to set as an example for what we have. The reason will become more clear in a few questions when we have to use this. But for now, chalk this up to what an identity looks like for the tensors, and just be aware that we will have to use it at some point. So I would go ahead and see if you can verify the other one temporal dimensions to match the other curl directions, and let me know what you get. Till next time.